What we're working with in this question is we're looking at composite volumes of shapes and how they come into play with one another. So what we're told here is we've got a concrete block. It's in the shape of a large pyramid with a small pyramid removed. What I want to do is calculate the volume of the block that is there. Now we're given all the dimensions that we need for both pyramids. We just need to figure out how to do it. Well, this one is very similar to composite areas, but with something removed. If you think of if you're looking down on the top of a donut, for the area of the donut that was there, we'd have to do the area of the big circle, the area of the small circle, and subtract them. This is a similar idea. We've got the area of the part that's left. So if we do the area of the full pyramids, then the volume, of the full pyramids, the volume of the smaller pyramids, and then subtract the small from the big, what we'll end up getting is the chunk that's left over. And then we'll be able to tell us what volume we've got left. So what we're going to do is we're going to do each of them individually, and then we're going to move on from there. So if I look at the volume of the small pyramid. Now remember, formula for the volume of a pyramid is 1/3 times the area of the base times the height. Now we're quite lucky that both of the pyramids are square based. So what that means is I can kind of write it as 1/3 times the length of the base squared times the height. So if I'm looking at the small pyramid, which is the top chunk there, I'm going to do 1/3 times, now the length of the base, which is 40, squared, and then multiply that by the height. And if I look at the diagram, the height of the small pyramids is 48, then it's times 48. That there will give me the volume of the smaller of the two pyramids, which in this case ends up being 25,600 cubic centimetres. What I can then do is the same idea and do the volume of the large one. Now I'm going to use the same formula. It's not a different shape. The only thing that's changed on it are the dimensions we're going to use. So it's going to be 1/3 times the length of the base squared. Well, in the big one, the length of the base is 90. So it's going to be times 90 squared. Then it's going to be times the height. Now on the diagram, 60 centimetres is marked as the height of that small chunk. But we want the height of the overall pyramid, remember. So the overall pyramid's that chunk at the bottom plus the pyramid at the top. So it's then times 108, not just times 60. If I were to do that, what I'd end up getting is 291,600 cubic centimetres for the entire pyramid's volume. What I then have to do is realise that the volume of the block is equal to the larger volume take away the smaller volume. So in this case, what I'm going to do is 291,600 take away the 25,600. If I do those two calculations and I subtract them from each other, what I end up getting is 266,000 cubic centimetres. And that there is the volume of the shaded part there in the diagram, or the volume of the block. So it's a fairly straightforward question when we're able to extract the information out of it, and when we start to get rid of information that's not there, that's stuff that's not relevant to us. Now, key thing as well is remembering about composite. If we think of composite or compound shapes, regardless of whether it's 2D or 3D, what we have to remember is that's somehow combining more than one shape. Whether that's adding together or taking parts away, which is this scenario here. Now this question is worth 4 marks. You get 1 for each of the two volumes, volume of the small, volume of the large. You then get 1 mark for knowing to subtract the small from the large, and then you get 1 mark for your final answer. Now, a key thing with this final answer, it explicitly states in the solutions that if you do not put the units in that final answer, you don't get the mark. This is an example of why units are vital in mathematics. If we don't have the correct units in a question, what that means is we can't interpret it properly. We don't know what it's referring to. In this question, we are changing from a length to a volume, which means our units change from units of length to units of volume. We have to show that we understand how that happens and what it means in the scenario. So we have to include cubic centimetres in the final solution. If we don't get that mark. So be very, very careful about it. We don't have to change it beyond that. We just leave it as 266,000 cubic centimetres. And that there is more than enough. So there's a couple of little intricate bits in there that you have to make sure you remember. So there's a little bit more digging in this question than there was in some of the previous ones. But the techniques used are the same as what we've done previously when it comes to volumes. The techniques that we've used are the same as previously when it comes to units. The techniques of compound shapes are the same, i.e. big one take away the small one. All of that theory behind it is the same. The biggest change is the numbers and the numerical values involved. They're bigger, so they add a level of complexity to it. So watch out for those, but bearing that in mind, once you extract that information and we know the steps that we're doing and we know how we're going on about it, once you start to get into it and start to get the numbers going and get stuck into the maths behind it, get your head around it, this question starts to become a bit more straightforward. Once we get our brain into gear, it becomes easy peasy, lemon squeezy.